Okay, so in the last video we discussed about the curse of dimensionality, which means what are the problems if we have for each object if we have a lot of features that are available. On the one hand, having more and more features available give a lot of information about the object and it makes sense to assume that having a lot of knowledge about the object will give us a better understanding of the pattern, and we can but that brings the problem that to understand the exact pattern or the better pattern you need a lot of data points in the presence of a lot of features. So if the dimensions of the feature space is high, you are going to need a lot of data points um, to actually find out the pattern, to actually find out the distribution of the data. A related kind of some problems are there in which the data points are not available in much quantity. In particular, if your feature space is high, I mean too many features, and but your total number of data points are small. If D represents the dimension of the feature space and N represents the total number of data points available, if D is greater than N, then this kind of data set falls in, in a problem category that is called small sample size problems. And there are, fascinating and very great algorithms to handle these small sample size kind of problems. One such algorithm is Fisher's linear discriminant, FLD. Another recent algorithm is null Foley summon transform. There are others, but handling this, this null Foley summon transform, sometimes also called null LDA. Um, um, don't worry if you don't know these terms, that's okay. Or am I saying that if the problem falls under this small sample size SSS problem, there are some specialized algorithms to handle this kind of problems. And on extreme case, this might be possible that per class, for each class, you have only one sample available. So let's say you have 70 classes in your data set, 70 different classes, and the total sample points are also 70. Each class For each class you have only one sample available. That's bad for learning because we require more and more variety for each class to understand the pattern better. But um, in some situation this happens that we cannot have a lot of data points for a lot of samples for each class individually, and these kind of problems, the solutions to that the solution to that is a better solution to that is one-shot learning. That is a kind of recent learning technique that appears in machine learning. One-shot learning relies on deep neural networks, which is some kind of advanced machine learning algorithm and architecture. And it is also proven to be these deep neural networks are proven to be good for statistically they are proven to be good for these kind of problems. So if you don't have enough data, if you don't have a lot of data for each class, if you have data samples that are small, that's having more and more data is always good, but in some situations you cannot have access to a lot of data. Even in that case, there are specialized learning algorithms that exist, and they help you go through with those kind of problems. um, okay, so that was basically very brief and maybe very fast introduction to a lot of the terminology of machine learning. And knowing these terms, knowing what these terms mean, will help you understanding the material about machine learning on the internet. Will help you understand them will help you understand different algorithms. I have not talked about any particular learning algorithm yet. There are several algorithms, including the linear regression, logistic regression, decision trees, support vector machines, random forests, neural networks, and whatnot, RBF networks, and I mean, there are several machine learning algorithms. But these terms that we have discussed so far, I mean, that these terminology, they are more or less common to all these algorithms, and knowing these terms will help you understanding the working of any algorithm in a much better way than otherwise. That's great to have now a vocabulary of machine learning now with us. In the next video, we are going to see uh, the something about data, um, how to encode data so that it becomes ready for any machine learning algorithm, how to prepare the data. So let's see you in the next video.